conquer nature. Through science, technology, and research, human beings are able to manifest the power of innovation and organization and show miraculous results. In case of our country, the role of science and innovation is even more important since our need for development on several fronts is acute. Therefore, we can hardly ignore the role of science, technology, and research anymore in managing health securities. I am sure that this FDP will help in shaping the vision, new ideas from academic professionals and researchers. This FDP will also identify new avenues of research for teachers who thirst for the knowledge and excellence. I would like to express my appreciation to the organizing committee for their dedicated endless efforts to materialize the FDP. I do hope all participants will have a fruitful and beneficial experience. My best wishes to all for seeking the path towards gaining and spreading knowledge. Lastly, I would like to say few words to young generation that a big challenge before the world today is to sustain economic growth in a manner that does not adversely affect our natural assets. Our forefathers left a beautiful planet for us to enjoy. In careless use of resources, unfortunately, we are living on borrowed wealth from future generations. It is our moral duty that we learn to use these scarce resources judiciously. We need to develop new sustainable development models which support conservation of resources and healthy environment for future generations. Lastly, I am highly obliged our President Architect Achal Chaudhary. He is the dream icon for thousands of our students. He kept faith in us and permit to allow to host this 1 week FDP. Thank you very much.
Thanks a lot, ma'am, for the worthy information of IPS Academy and motivating our participants. Now I request Dr. Pradeep Joshi, sir, convener of the Faculty Development Program, to inform you about this FDP. Pradeep Joshi, sir, please.
Good morning to one and all present in this online FDP development program. I, Dr. Pradeep K. Joshi, on the behalf of Institute of Science and Research, IPS Academy, welcome you all in the national level online FDP program, Advanced Opportunities and Implicit Research Technologies in Sciences. It is our great pleasure and honor to welcome you all. A very warm welcome to our chief guest and resource person, Dr. Rajma Jain sir, retired space scientist, PRM, Ahmedabad, Gujarat. I am very much thankful to the President IPS Academy and Chief Patron of FDP, Architect Achal K. Chaudhary sir, and Principal IPS Academy and Patron of this FDP, Dr. Premita Gupta madam, for providing guidance and motivating us to organize this FDP in this lockdown period. I am pleased to inform you all that there are about 950 participants from different states, MP, Gujarat, Tamil Nadu, Maharashtra, Chhattisgarh, Karnataka, and other states are joining this online platform, which clearly shows that even this lockdown and pandemic cannot stop them from learning. The aim of the FDP is to know recent advancement in various disciplines of science and integrate innovative research ideas to strengthen research. This FDP has a wide scope for multidisciplinary science streams for the research scholar and faculties. It will provide us an outspread opportunities to attend lectures to eminent speakers worldwide, which will help us to understand new innovations and knowledge, skill, and professional competence. In this FDP faculty development program, there will be 2 sessions each day. From first session from 11:30 a.m. to 1 p.m. and the second session will be start from 2 to 3:30 p.m. I am proud to say that the following eminent speakers have given their consent to speak in this virtual program. We feel highly obliged that they are giving us valuable time for this FDP. The eminent speakers are Dr. Rajmal Jain sir, ex-scientist, PRL, Ahmedabad, Dr. Chandra Maladi, Senior Scientific Officer, Sydney University, Australia, Dr. Sudhakar C. Agarkar sir, TFRI Mumbai, Dr. Sanjeev K. Pathak sir, ISER Bhopal, Dr. N.B. Singh sir from Noida, Dr. Narayan Kalakure from Chennai, Dr. Pathik Shah, Sipet, Gujarat, Dr. Tariq Raja from Jammu and Kashmir, Dr. K.K. Verma sir from Jabalpur, Dr. G.M. Bhalerao from Scientist, and Dr. Neeraj Chaurasia sir from IIT Delhi. I am also thankful to my colleague, Dr. Jiten Tripathi, Head Department of Department of Physics, Dr. Sanjay Nagar sir, Head Department of Biotechnology, Mrs. Ruchi Srivastava, Head Department of Chemistry, and Sapna Jalore, Madam, in charge of Library Science, and all the team members of the organizing committee and my colleagues. Without their sincere efforts and hard work, it was difficult to organize this program. The lectures of eminent speaker of the FDP will definitely benefit faculties, research scholars in the field of multidisciplinary sciences with practical development in their research work. I wish you all a happy learning and all the best. Thank you.
Thank you, sir. Our today's chief guest and our speaker of this session is Dr. Rajmal Jain, an internationally acclaimed space scientist of Physics Research Laboratory, Department of Space, who has made fundamental contribution to the development of solar and planetary physics and related instrumentation in India. There is a lot to say about Professor Rajmal Jain ji, which is not possible to cover in short span of time. Still, I would like to give his brief introduction. Dr. Jain is one of the founders of the Udaipur Solar Observatory. Professor Jain is project director of Solar X-ray Spectrometer Mission, first space-borne solar astronomy experiment of India. He was also involved in other missions planned for Chandrayaan, Mars, and Aditya. He made several instruments for space experiments. He has published more than 120 research papers in international peer-reviewed journals. He represented India in more than 100 countries and delivered more than 230 academic talks, popular and public lectures in several international institutes and universities. He guided 6 PhD students, and currently 4 students are working under his supervision. Dr. Rajmal Jain took post-graduation in physics from University of Udaipur in 1974. He did PhD in solar terrestrial physics at PRL Ahmedabad. Professor Rajmal Jain is the first Asian to receive International Young Astronomer Award for NOAO USA in 1984. I'm proud to say that he is honored with SAARC Countries Resource Person Award in 1996 by Ministry of HRD, Government of India. His first foreign visit was sponsored by the then Prime Minister of India, Mrs. Indira Gandhi, late Mrs. Indira Gandhi in 1981 as a Prime Minister Fellow to attend international conference in USSR. He was honored with Saraswati Putra and Jain Putra by Acharya Shri Kanak Nandani Gurudni Shri 1996 and 2010, respectively. He received a fellowship of Gujarat Science Academy in 2010. He was honored and felicitated with Lifetime Achievement Award in 2013 by the Government of Madhya Pradesh for outstanding research, high-tech instrumentation development, and education reform in rural India. He received highly prestigious award from Royal Astronomical Society UK in 2014 in recognition to his discovery of iron and nickel in the solar corona. On the other side, Dr. Rajmal Jain Sir has made significant contribution to the Jainism. Particularly, he has contributed scientific aspects of Jain philosophy and canonical text. He is very actively involved in Ahimsa mission to resolve the global challenges. He played key role to discovering Chandraprabhu Temple in Ethiopia and connection between Karal civilization and Niganta tradition of Jainism in Peru. He has established the existence of Shravan culture before the Neolithic period. He also estimated the period of Sri Rishabdev, first Tirthankar of Jain tradition, to be more than 140,000 years before present. Now I request Professor Rajmal Jain sir to take over the digital platform and kindly give keynote address for the inaugural session. And then you please continue your lecture and shower our participants with your immense knowledge and blessings. Topic of today's lecture is
Hello? Hello? Can you hear me?
Yes, sir.
Shall I start now or what?
Yes, sir.
So can I share my screen now? Can you remove this?
Yes, sir. We are removing.
Sir, yes, sir.
Oh, yes. So now first I would like to confirm whether are you able to hear me and I'm visible also both?
Yes, sir, you are audible. Please go ahead.
Audible and I'm visible also?
Yes, sir, you are visible.
Okay, very good. So first of all, good morning. And I welcome to all participants for this program. Actually, I'm always proud of to participate in any activity of IPS Academy. पीछे से बहुत आवाज आ रही है, बहुत आवाज आ रही है. Can you? Yes. Please mute all those noise. Then only you will be able to enjoy. Are you able to hear me?
yes, sir.
There is some noise from some house. Somewhere.
Technical team, please mute the other participants.
So I'm always associated with many activities of IPS Academy, and I'm proud to say that I'm associated with IPS Academy since last 15 to about 18 years. Well, this program, that is Faculty Development Program, is really a magnificent activity by Institute of Science and Research of IPS Academy. When I was actually, I received this whole program, I'm really overwhelmed with this. So at the outset, first of all, I express my sincere thanks to the IPS Academy organizers of this FDP program, and particularly to Professor Tripathi of Physics Department, who contacted me and invited me for this program. In fact, other thing also, if you see that the title of your FDP, that Advanced Opportunities and Implicit Research Technologies in Sciences, means that itself suggests that you are interested not only with your master's students or research scholars, but the faculties also to participate actively in this advanced opportunities. In this connection, I am also going to talk about the research and career opportunities in space sciences. As you know that the space sciences currently is one of the advanced subject, and in which every student has a dream to contribute and do some good career to do some research activities and make a professional career in space science. Now I humbly request all of you to kindly mute your uh, earphones, your sound, and I hope you will enjoy my talk. So whenever we talk about the space, dear friends, we always fascinate the sky, particularly when we see in the night and in summertime at the terrace of our houses. We see large number of stars, planets, and even sometimes the dusty galaxy. And we have in mind number of questions right from the childhood stage. The first of question comes is, what is this space which we are talking? आखिर यह आकाश है क्या? यह अंतरिक्ष है क्या? And where it is located? From where it starts above the surface of the earth? These are some big questions. Then there are another still major questions: how this universe, how this space was formed, how it came into the origin, and whether these stars were there right from the beginning or they are actually taking the birth and then they also die. All these questions, when you talk to the children, then they will ask many even other questions, including these questions. If you ask youngsters, those who are in undergraduate or even in masters, they will also ask such similar question. And the first question would be by them that from where this space begins. Okay, on the right side of this slide, you can see a plot where I have shown this graph on which x-axis are the quantities increasing from the left to the right, and on the y-axis it is the altitude above the surface of the earth in kilometers. Now you are very much aware about the atmospheric structures because we have been studying from the school time about the troposphere, stratosphere, ozonosphere, etc. Hello? स्लाइड शेयर नहीं हुई है, फिर से करता हूं मैं. ओके.
Excuse me, sir.
Are
I
you not
can't see your screen, sir.
are you not able to see my slides?
No, sir. You haven't shared them.
Okay, I will
Thank
reshare.
you, sir. Thank you, sir.
I don't know where I have now slides. Are you able to see my slides now?
स्क्रीन आ गया आपका।
Yes, sir.
मेरा स्क्रीन आया है?
आया सर, आया सर।
Yes, sir.
आ गया
Are,
sir।
Yes,
are you
sir.
able to
Yes,
see my
sir.
slides? Are you able to see the
Yes, sir.
slide?
Yes, sir. Now it is good. Thank
Okay.
you, sir.
Okay, it's okay. So on the left side, you can see the night sky, as I was saying, and there are a large number of questions. On the right side, what I have shown is a plot, a graph of our atmospheric structure. On the x-axis, the quantities like temperature, pressure, density, sound speed, etc. are keep on increasing from left to right. While on the y-axis, actually what we see is altitude, that is height above the surface of the earth. Now, you know that our atmospheric structure is divided into the various kinds of atmospheric layers like troposphere, stratosphere, ozonosphere, mesosphere, and then thermosphere, ionosphere, etc. as a function of the altitude based on the characteristics of the temperature, density, pressure, etc. and the chemical compositions in those atmospheric layers. Now I would like to have your kind attention about these two quantities, pressure and density. As you go above the zero height to say about 20 to 30 kilometers, what you will see that pressure and density almost go to the zero. That is at the 30 kilometer, almost zero, but not, I mean, completely zero. But on the other hand, you can see that the other two quantities, temperature and sound speed, surprisingly, first they decrease up to 30 kilometer and then they again increase at 50 kilometer and then again they decrease and then increase. So the temperature and sound speed profiles, they don't go to zero, rather they are keep on dancing between the minimum side to the maximum side. That itself suggests that the sound, the speed which we speak on the earth is not the same as a function of the height above the surface of the earth. It is keep on changing. And there are few such, I mean, parameters, such proxies based on which the space scientist community, they decided that where we should say this space begins. In the beginning, at some countries, they decided that 30 kilometer we should consider, but then most of the countries, most of the scientists finalized 50 kilometer above is the space begins. Nowadays, some countries like USA, etc., they consider that the space begins above 100 kilometer. Anyway, does not matter whether the space begins at 30 kilometer, 50 kilometer, or 100 kilometer, but the space, as a committee of space research, decided that we will consider the space right from the 50 kilometer above the earth, and that is very important matter. So now, if you see in this slide, that when I talk about the pressure, density, temperature, and the sound speed, etc., they all look the parameters of physics oriented. People generally consider the space by misleadingly that the space actually is comprised of the physics community. No, no, friends. I would like to say space is not only for physics community. It is basically a multidisciplinary subject. It is comprised of physics, chemistry, mathematics, biotechnology, life sciences, earth sciences, geology, etc. All those science subjects which we study on the earth in our schools, colleges, and engineering. So you must consider that space science is basically a multidisciplinary subject, and not only of the basic sciences, but also of engineering field and technology. Because if you want to study the many different experiments you have to conduct, and they need the very high profile engineering and aerodynamics. So engineering is also very well integral part of this space science and technology. Okay, to motivate my young students over here, they are participating in this FDP program, I would like to ask them, just think, if I give an opportunity to you, just think three careers in the space sector which you may like to do. What you will come? I'm just giving you a few seconds to think. Okay, you will come to your some kind of a conclusion in your mind, and you will end up that, oh yes, there is a big opportunity. Even I'm a biotechnology student, but I can become a research scientist. I can become engineering. People can think I can become a space technologist, space engineer, and of course, those who are even highly motivated and want to become a pilot and want to take their profession and future career as an astronaut, that is another future. So what I recommend to research scholars as well as those students in masters to choose their profession in space sciences, because there are ample opportunities in space, lots of opportunities at the moment and present time, and even after the corona pandemic, there are ample opportunities in research in science, space sciences, as a research scientist, as an engineer, as an astronaut. So what kind of research scientist you could actually think of? Let us say if you are from a physics background, then astrophysics is basically a main branch which you generally consider to be as a part of space sciences. Basically, astrophysics is also a multidisciplinary subject of the physics itself. It does not consider that only physics, some classical mechanics or quantum mechanics itself will be the main subject over there. No, it includes all the disciplines of physics branches like plasma physics, nuclear physics, statistical mechanics, quantum mechanics, and thermodynamics, etc. And how we do the research? As a physics person, if you ask me, what we are doing, we are not using any additional things from the space which are or from the aliens who will tell us what to do. We are simply using the methods and principles of our physics, which we have been studying from the schools and our undergraduate time. What we are doing that? Those principles and methods we are applying to study the celestial objects like sun, moon, planets, stars, galaxies, etc. And how we do, we can observe. I think there are some naughty students who are playing some lines on my slides. Can you stop that, your digital tactic team, to remove this? So what we have to do is emission which is coming. That emission we have to study, which is coming from this object. Now emission, if you split up on the whole electromagnetic spectrum, then you can, first what we do is the visible spectrum. Then you go to the left side, gamma ray, X-rays, EUV, UV, and on the right side, you can go to the infrared and the radio, millimeter and submillimeter, etc. So you can study this and derive from these observations from the spectroscopy, as well as doing the imaging of these objects in these different wavelengths. You can derive as a function of space and time, the variation in the many properties like pressure, density, temperature, whatever the motions they are taking place, the motion from the images, etc. So we can study many things and do the advanced research work in that. Then the subject comes is astrochemistry. This is a very wonderful subject, I would like to say, because using this astrochemistry, we can study the composition and reactions of the atoms and molecules and ions in the space. And when you study a planet, let us say, so in the planetary atmosphere, what is happening over there, you can observe and you can derive the various kind of composition and reactions which are taking place. So astrochemistry is also a very, fundamental, it plays the fundamental role in space sciences. What generally we do through the astrochemistry or in the chemistry itself, we do is the spectroscopy study, right? So we have to do the spectroscopy study for the various kinds of this diversified planetary atmospheres or the composition of the stars, etc., or the interstellar matter or the interplanetary space. And I would like to just give you a very big, I mean, the result which we came in last 2 years in astrochemistry. I would like to mention this to motivate my friends at IPS Academy and others, those who are hearing and who have background in the chemistry. You can see these two papers which are published recently in last 3 years in Nature. And you can see that what simple but high quality profile research work has been done by them. That is direct observation of long-lived cinnamide anions, super excited states. See, this is also related to the life science. So it means chemistry along with the biology, that is biochemistry kind of thing, has been used. The other thing is the second, organometallic compounds as carriers of extraterrestrial cinnamide in primitive meteorites. So this is very important. This point I wanted to bring into the picture in my today's talk, that we have been knowing since our school time or in the college time that the comets, meteorites, they actually in our solar system, we always consider that they have the primitive, very primitive original soup of the life. And we also think that even the comets or meteorites which fall on the Earth or on other planets, they deposit their life material over there. Now, how to know that, how to study that, so this life sciences, biotechnology, and chemistry, along with the physics, etc., they play the key role for this. So, what I would like to conclude for the chemistry faculties and students, that they should consider space science as a really boon for them, and there are many, many ample opportunities in astrochemistry. For the life sciences, that is for the astrobiology, which is actually a subject combined. I am audible. Can you hear me? Hello?
Yes, sir.
Yes,
Yes, sir.
sir.
Yes, sir.
Can I request you to remove these lines on my slides? Some student has done this notorious thing. Can you remove these blue lines on that by any software?
One Mr. Nagaranjan, please remove these lines.
Okay, very good. Please do that. So what I would like to say, that along with the physics, chemistry, mathematics, this biology, that is biotechnology people or life sciences people, I would like to motivate them. In fact, on the contrary, I would like to say that this is the cream time. This is the cream time for biology people to play a big role in space science, because this subject is related. It is related to explore the possibility of life out of the Earth world, that is out of the other this world, where this we consider planets, other planets of the other stars, etc. That what we call as exoplanets. So, how to discover the life or the origin of life on those planets? How the material of life was, put up over there, or whatever we are thinking as of now is completely wrong, and there is something else, completely different original idea may come up. As I told, currently we are thinking that the primitive material is in the meteorite or in the comets, etc. But there may not be comets for other stars, stellar systems. So this is a very, very important subject. Now only this astrobiology people, they should have a background of all other multidisciplinary subjects like physics, so that is biophysics, then biochemistry, even the biogeology, earth sciences people also have to participate in that. So this subject is of very, very much important, not only for Indian Space Research Organization, but also for NASA, for ESA, for Chinese Academy of Space Sciences, for the Russian Space Sciences, For the French, also people are looking forward, and many other countries, wherever the space programs are there, like Canada, etc., they are actually wish to hire the Indian student. They prefer that for those who are very talented in the life sciences and they want to give job in the space biology. So they must also consider, and even India itself is now, astrobiology is actually going to be a prime area of research in a space science program. As I told just now, that the comets basically, which come all the way from very far from this in our solar system, very far, and they actually come as a very small icy object, very small icy object of few kilometers. You can see somewhere here, that is the we call as a nucleus, and it may be a few kilometer by few kilometer, but when it comes very close and close to the sun, then because of the radiation pressure from the sun, it actually all that dust that is deposited inside that nucleus spreads out, and we call that which complete, I mean, exposes outside and then spreads, we call it a dust tail. But more recently, in last 50 years, through the satellite program only, we could learn that this radiation pressure, when it comes, then the radiation pressure is too much, along with the very high temperature, then this dust actually also gets ionized. So it spreads into the electrons and ions, that is known as the plasma tail. So every comet, by and large, now it has been realized that it has the two tails. One is the dust tail, the second is the plasma tail. Then when the comet fell down in the past history, and it was analyzed many samples, then very originally it was discovered and told that it was mentioned, it has been established very well in the world that the comets actually bring the soup, the life soup which is hidden inside them in that small nucleus, and when they fall, then they start the life. So life actually began on the earth also from the material which was brought by these comets. So the exploring the life in the space or in the universe is an important area currently, and in this connection, some big program was started, which is known as the search for extraterrestrial life or intelligence, search for extraterrestrial intelligence, SETI. SETI was the program which started some 50, 60 years back. And in that program, it was defined that, okay, there may be life on other planets, but how we will know that what is the appropriate location of a planet of a given star system? So that was known as, described as a habitable zone. Habitable zone was described based on radiation pressure which is coming from the main star, that is the distance, appropriate distance, pressure and densities on the planet, and then how much time it takes to go around the main body, that is the revolution period, just like Earth takes 365 days to go around the sun. Those kind of parameters were very important, and finally, the sustainable temperature on the planet. So what happened? The different kind of mass of the stars was taken, which I have put here on the y-axis, relative to the mass of the sun, and on the x-axis, the radius of the orbit of the planet of that star system was plotted here. And I have shown for the sun, this is the sun, which is one solar mass star. And I have shown over here our all 8 planets and 9th dwarf planets out of that screen. You can see here that whenever this blue belt, this is very interesting plot, and you all may, particularly physics, chemistry, and astrobiology people may like to give attention that if there is any star which has the low mass than the sun, the habitable zone will be very close to them. While on the contrary, if the star like 2 solar mass, than the habitable zone, that planet will be very, very far away from them. So even in our own solar system, if you see that the sun is here and after 15,000 kilometer, 15 crores of kilometer distance, the earth is here, and that is only having the some 5 cents life over here. There are some life organisms on the Mars, etc., on the Saturn and other places, but not the people like us. So how to search the human? That is the astrobiology, a main primary question. How, if their life exists, how to detect it? Means the technology is also required. Engineering is required because we need to develop the biosensors. Well, what I would like to give an impression that this is the picture taken and composed over our own Milky Way galaxy. Now all these bright points which you see over here, these bright points are some kind of a solar systems, like one which I have shown over here, our own solar system, which is very close, so very radiation light is there. Am I right? Am I audible? Am I right? Okay.
It taught us many things. Here
Yes, sir.
you can see the similar kind of a construction is available in our country. So not only we are making single story and two-storied building in an extensive way out of this masonry. Whether you are talk about brick masonry, block masonry.
Hello, I'm audible.
Around 60%.
Yes, sir, you are audible.
No, there is some another lecture is going
So
on.
here,
I just searching.
I am audible
Yes, sir, you are audible.
because there is another lecture which is going on over there. Can you mute that? Okay, because I'm going to tell you. So you can see now all these are the solar systems where the life is possible, but they are very, very far. The far means not by few hundreds or thousands of or millions of kilometers. The distance is in light years. And currently technology is not, sustainable or suitable to detect the human life over in this planet. But these are the systems where they have the planets where the life is possible based on the what I told, the parameters of the search for extraterrestrial intelligence. Okay, this exploring the life is not only a recent issue. It is not only very recent issue. It was told in our religions and philosophies also in the past. If you remember that in Hindu philosophy, Jain philosophy, as well as in Buddha philosophy, there is a one Dvipa which is known as Jambu Dvip. I hope many of you, even youngsters also might be aware about the Jambu Dvip. We always talk and we say that this Jambu Dvip is consisted of 7 zones, that is kshetras, and these kshetras or zones are nothing but the solar systems. And in earlier epic time, that is in Jambudvipa manuscript, they told that they were known, these solar systems were not known by the name of the planet where the life exists and not by the star name. Like currently in modern science, we call as a, because of the sun, we call as a solar system. But at that time, wherever the life exists, by that name it was given. Just like in our solar system, the name was our solar system was given as a Bharat Kshetra, where the whole Earth is the main planet where the life exists. Similarly, Mahavidya Kshetra, then Airavat Kshetra, Ramya Kshetra, etc. Some 7 zones are there. Now, what we have done recently as a very preliminary study, we identified in view of all these, which I showed the various solar systems which are visible with the exoplanets, we tried to identify the main star around which these planets are moving. And name of this planet also we found, and we gave that planet along with the modern what astronomers have given. So you may ask me a simple question that on what basis we have done this exercise. So I would just give you a very brief example of two or three. Just like our Bharat is the sun, is the main, I mean, it's principal star. Then basic study which says, and it is necessary to know all of you, is the spectral type of that main principal star. So it has been known that the G-type stars, K-type stars, and M-type stars only they can have if they have the planets, then they can have the life over there. So what are the three things, spectral type of stars are important? The one is the G-type, K-type, and M-type. Now, for Earth, it is most suitable because the sun has a G2V spectral shape. Its mass is 1 we are considering. And for all them, what we have done is the relative to the sun, then the radius of that star, then the flux, that is the radiation which is coming. Then we are considering the Earth kind of systems. So how much temperature is there, how much revolution period around the star, and then how much distance in light years, etc. Now, if you see the Mahavidya Kshetra, then the Kepler-22 is the main star around which Mahavidya Kshetra, that planet Mahavidya, is revolving around. And you see that it's a very good, it is a G3V star. However, because its mass is very high, so the distance also from the main star, should be very large. But its temperature and its revolution around the principal stars are very close, like our Earth only. And similarly, in the Airavat Kshetra, another star, main star of the Kepler series only, and the name of the Airavat is Kepler 422b. These are the actually given names by the modern astronomy people in catalog, what we call as a new generation catalog. And you can see, so rather by eye observations and whatever by meditation they had given, and they told that there are many, many planets, not the Earth, but the many planets in the universe. That is, it appears true. Okay, so far what modern science has done, that we have already currently discovered 6 solar systems from G spectral type, and they all have the exoplanets where the habitable zone exists. Currently, a total 15 planets, I mean exoplanets in the K spectral type have been discovered, and out of that, 12 are the potential candidate for the habitable life. Similarly, total 28 actually exoplanets from the M-type stars have been discovered, but because as we go from G to K and to M, the temperature of the surface of the star goes down and down. So M-type stars are very, very cool, and so the only very small one single sense or 2 sense creatures, like that kind of life exists. So what I would like to conclude from all this and motivate to all research scholars as well as faculty, that there is a big scope in astrobiology, in space biology, and you should make your profession, you should become a research scientist. You can make this space biology as your career. Now another big subject is astronomy and solar physics. Basically why it is told that it is a cream subject, why we should go into this astrophysics, astronomy and solar physics, etc. There are 2 important scientific concepts. If you consider the sun as a closest nearby Rosetta Stone, some kind of astrophysical laboratory, then you can do wonderful experiments, you can do wonderful research in solar physics as well as sun-earth relationship. On the other hand, if you consider these black holes as a props of stellar and cosmic evolution, and to study all these astrophysical objects with different masses and the scales, density, and the other parameters, then you can address many questions related to the astrophysics. Like what recently there are many questions like when this universe was actually evolved, what are the galactic and large scale structures? What are the processes for the formation of the stars, galaxies, etc. And more recently, more recently, the whole astronomy, astrophysics is questioned. In fact, and that is why this astrophysics has become a popular subject in recent time. And that happened in last 50 years, because once we found that the visible mass or whatever we see in the universe, that stars, galaxies, planets, or whatever we see, it is only 4% of the total universe. 96% is missing. We are not able to see. Means the visible universe is almost insignificant relative to the invisible universe. An invisible universe is composed of this dark matter and dark energy. Dark matter, it is proposed that 21% matter is dark matter and 75% is the dark energy in the universe. Now there are many questions relative to this dark matter and dark energy. Nobody has practically physical has seen. There are different kind of proofs have been given, but there is an ample, scope in searching, in doing research in dark matter and dark energy. So I will strongly recommend to those students who are in masters at this time in physics and chemistry and biology, and even the mathematics, because modeling is much more important, the computational modeling. And so those who are already in MSc, not as a research scholar, because you already have gone to some kind of selection of your work, but those who are in master's degree, they should plan that they can choose their work, future career in astronomy, astrophysics, and solar physics, etc. There are many other questions, dear friends, relative to the formation of the stars with planets, and planets like Earth. And so considering the sun, as I told in the beginning, as a very close laboratory. It is actually a real laboratory, cosmic laboratory. And not only that, but it is a nuclear laboratory, it's a plasma physics laboratory, it is a mathematics laboratory, and you can do many experiments from the radiation which is coming from the sun and the charged particles which arise from the sun when there are explosions and when they continuously from the solar corona, that is known as solar wind. So basically considering this, I also thought that I should tell you a little bit briefly about the sun. This is the picture of the sun, where the core at the center of the sun, the very high temperature exists, almost 15 million degree K. And as a result of this 15 million degree K temperature, the thermonuclear fusion reactions take place. And those thermonuclear fusion reactions, as a result, hydrogen, which is the main element of this sun or all the stars in principle, or in fact, if I extend, the whole universe is composed of the hydrogen basically. So this hydrogen is continuously being converted into the helium due to thermonuclear fusion reactions. And as a result of those thermonuclear fusion reactions, every second 40 million tons of energy is released, which finally being transmitted first in the beginning as a gamma ray energies, which gamma rays energies actually comes into interaction with the ambient material over there. So every time through every interaction, it loses its energy, then it comes, that photons are thrown in the radiation zone, and finally that whole energy stops over here in the convection. That all photons, which the energy was being carried by the gamma rays to the X-rays to EUV, then UV photons, and finally it stops and it comes over here. And from here, it comes to the first layer, which is visible in the sky of the sun, known as photosphere. It is actually transported through the convective bubbles like what we see in the boiling water. So actually it comes as a heat at the top. So the temperature is about 15 million degree K at the top, at the center of the sun. It comes almost 6,000 degree Kelvin at the photosphere. That is the first surface which we see over here. And then above that surface, again the temperature goes 10,000 degree at chromosphere, and in corona almost 5 million degree K or so. Now there is a very interesting phenomena which takes place on the sun. And this is what I would like to briefly tell to my young people who are undergraduate or postgraduate and research scholars, that the sun is basically, as you have seen with this description, that it is a purely hydrogen gas and helium gas and charged particles. Okay, so means there is no solid, no liquid, and so sun itself as a is a plasma body, and this cannot rotate at its own axis as a solid body. As a solid body, like Earth rotates around its own axis in 24 hours. Rather, the sun moves or rotates at the center of its, that is at the equator, very fast, just in 25 days. And as we go up and up, for example, at 30 degrees in the latitude, it will move, it rotates in 27, 28 days. And at the pole, it rotates in 36 days. What does it mean? It means the sun does not have a one single type of rotation speed and the rotation period. Rather, it has the differential rotation system. And as a consequence of differential rotation, and as a, as a result of this electromagnetic body, it has north and south poles, like Earth has north and south poles, because the sun is basically a very high conductor. It is an electric body. So at a perpendicular of that electric body, it will have magnetic poles. Now this magnetic poles, that north and south, they will also be connected by the lines of force as we see in the bar magnet. So what it happens, the similar kind of thing. Can you see my, in my image, in my own face, can you see this rubber band in my hand? Can you see
Yes,
rubber
sir.
band in my hand? Is it okay?
Yes, sir.
Okay, very good. If you can see rubber band in my hand, then I would like to demonstrate what happens due to this electromagnetic body and because of differential rotation. As I told, that at the equator, it moves faster, but at the higher latitude, it moves slower. Now I'm just consider this rubber band, I have stretched it enough, and this is a sun. Now I'm holding at the equator and moving it faster and taking it one rotation complete. As a consequence, or as a result of one rotation, can you see that because it moved faster, there are two nodes, one in the northern side, one on the southern side. And if I take another round of the equator, which is moving faster, another nodes will be there. So like that, these nodes of the lines of force are nothing but the magnetic flux. What is magnetic flux? We know very well that it is basically number of lines passing per unit area. And so whenever this magnetic flux is stronger and stronger and stronger, then these nodes split up from
सर का शायद कनेक्शन टूट गया.
Technical team, please do the needful. Inform sir.
They are talking, ma'am.
Okay.
Participants, sir will join very soon. There is some technical issues. Wait for a few minutes.
Dear participants, we are trying to just resolve the issue. Please wait.
Origin.
Can you hear me?
Yes, sir, you're audible.
And now I'm again sharing the screen, okay? I have to share the screen again. Can you make me host? Hello, can you make me?
Yes, sir, yes, sir, we are doing.
Yes.
So you're co-host right now.
Yes. Can you see my screen? Hello?
No, sir.
No, sir. No, sir.
No? Okay. Can you?
Yes,
Yes,
sir.
sir, it is visible.
I am visible to you?
Yes, sir.
Yes, sir.
Now screen is visible?
Yes, sir.
Yes, sir.
Now it is visible.
Okay. So what I that those spots, and that is my interesting topic recently. I would like to show that this sunspots, when they are, that is a high strong magnetic field, and when the energy is stored, that magnetic field energy is stored over there, and it becomes above the saturation stage, then it explodes into some kind of a mass ejections known as solar flares or coronal mass ejections. Those explosions which are taking place on the sun, and those explosions affect the earth itself, its climate, its environment in variety of ways. Please just see this movie. That this all bright areas are explosions. These dark markings are the sunspots, which keep on moving from east to the west of the sun. And here I'm showing the big explosion that took place on the sun and which gave the big climate effect on the earth. So like that, it is very interesting subject, that the sun-earth relationship in view of space weather, the climate which is changing on the earth. And after this corona pandemic, there are many questions whether really corona, this thing was, whole thing virus was fabricated in China or in the space. There are many issues over there. But what I wish to convey in this slide, if you just notice that this is a plot of changing of the number density of the sunspot. So sunspots keep on varying. Numbers, y-axis is number, x-axis is the type. And from 1750, regular observations were available, and the scientists solar astronomers gave it a name as a cycle 1. And from then, it is already cycle 24 is finished. Now what I would like to have your kind attention, and please see on this plot, that the number density is not same in every 11-year sunspot cycle. That the cycle from minimum to minimum, it takes 10 to 12 years, that is about average 11 years. but in every sunspot cycle, sometimes the sunspot numbers goes above 200 even, and sometimes even it remains below 100. Now, what is meaning of that? That meaning actually is very significant, because whenever the sunspot numbers is very high, then the total solar irradiance, the luminosity which is coming from the sun is very strong. While when the sunspots are minimum, then because the magnetic field is very weak, so galactic cosmic rays will become stronger. So what I would like to have, and recently work which we have published in just 3 months before, and in the last month also, I would like to have your kind attention here in this slide. This is the actually sunspot numbers in cycle 21, 22, 23, and 24. That is starting from something like 1976 onwards to up to 2020. And what this kind of thing happened is a very surprising. That is, the sunspot numbers are continuously decreasing, which was never seen earlier, that continuously decreasing. Either they were increasing or sometimes decreasing, increasing, decreasing like that. But this time, since last 4 cycles, what we have noticed is the sunspots are continuously decreasing. However, although there was no data available earlier in the past, but we have done research work. Many our earlier researchers had done work exploring the number of sunspots on the sun. Now, recently, for the prediction of the cycle 25, how it would be, my 2 students groups, one in West Bengal in Kolkata, Partha Chaudhary, he, based on geomagnetic AP index, he predicted that the next cycle amplitude, that is the cycle 25, which will be peaking, that maximum will come in 2025, the maximum will be 100 number, that sunspot amplitude will be 100. While another group, Dipali Burud and all, the number we found using the spotless data, that is spotless days, and the global geomagnetic index, we've also found that 99 and 103 or something. So in conclusion, what I wish to say, that this cycle 21, the reduction started, it will continue even in cycle 25. And what does it mean? That because in cycle 24, it was about 114, and in cycle 25, it will be about 100 or so, means it will be further reduced. Now, whether it was earlier also like that, yes. Earlier in 1600, between 1600 and 1700, almost there was a situation, no sunspots, and that is what we called as a Maunder minimum. And earlier also, many such minimums at the gap of every 200 years and 400 years were seen. So every 200 or 400 years, whenever there are no sunspots or minimum, then we call that as a grand minima or global minimum period. Now, when global minimum is there, then what happens? This is very interesting thing to see. You see, the last global minima, that is between 1645 to the 1715, that is in the last 17th century, was also very cool. It was people call it also little ice age. And so many thousands to millions of people died in North America and in Europe, where the lot of ice was there for not only 1 day or 1 month or 1 year, but almost for 50 to 60 years. And as a result, many viruses, diseases actually came into the scenario. Now, this is an important time for this also time, that if it is so, then from 1600, that is 17th century and now 21st century, another 400 years gap is there. So this 21st century is again going to be critical. That is what we have estimated and published the papers. And accordingly, what happens, as I told, that whenever the large number of sunspots are there, total solar irradiance is very high. But whenever there is a weak, that is very minimum number of sunspots, then galactic cosmic rays are there. So that flux is there. It means galactic cosmic rays also produce either the clouds and the sea surface temperature rise, which another way total solar irradiance also does. So in any case, sea surface temperature rises, but the sea surface temperature, if it is continuously sunspots are reducing, then why it should increase? only galactic cosmic rays can play such a big role to enhance the sea surface temperature? This is a big question. And my one student, Kronal Patel, is doing work on that, and we published some good results out of that. I would like to show my dear friends, all of you, we have been crying global warming, global warming, global warming since last 50 years. But if you see in this, what I am showing over here, the temperature profile of the Earth of last 50 crores of years, 50 crores of years. Please, this left panel on this, from millions of years to the 500 millions of years, that is up to 50 crore years. And if you see thousands of years, then the almost 10,000 years to the 5 million years. 5 lakhs of years, sorry. So if you see our all picture, the temperature, please remember this slide. This is very important slide of my presentation, that temperature of the Earth is not increasing overall as on average. It is rather decreasing continuously in last 50 crore years. In between, there was a big study about the Malkovich period. That is the Malkovich periods, that the climate and the temperature and carbon dioxide that changes as a function of the Earth, various kinds of motion, just like a precession, the eccentricity changes, etc. So I'm now taking this period. So you can see this excursions, pulses are always there, but overall temperature was very high, around 50 crores of years, and now it is down. So now, if you see what happened in the last 400, 500, thousands of years, that is 5 lakhs of years, you can see this blue. This blue is the temperature deviation from our normal temperature, 15 degrees centigrade. So 0 refers to the 15 degree air temperature. Okay, or you can say even at presently, not precisely, but surface temperature, let us say. Now, after every 1 lakh year here, then here, then here, you see that the temperature was minimum, even less than that. So temperature of the Earth was some 4-5 degree, and what we call as a large glacier maximum, LGM. Large glacier maximum. Please remember. So the last large glacier maximum was somewhere around 25,000 years only. So we are actually generation, we are intelligent of this period. But the period when we go, the Paleolithic, that old Stone Age, it is almost this 400,000 years, 4 lakhs of years. Or the Jain community call is of Sarpani, or the what Hindu community call as a the Kali Yuga or something like that. Then this is the period of Rama, and then what we call Neolithic period, that the new Stone Age is of about 10,000 years, starts somewhere here, and after that start of Neolithic period, when the people started to become little intelligent, and about 6,000 years before present, or you can say 3,500 years before BCE, this Mahabharata took place, where the large number of people were killed. Then the Mahavir and Gautam Buddha took the birth over there. So the main talent came only if we conclude that in last 20,000 years or about that period. But before that, many things happened, and you can see that the green line, which is the carbon dioxide. So whenever the large glacier maximum, the carbon dioxide also goes down and down. So remember, when the temperature goes up, the carbon dioxide content also goes up. When the temperature goes down, carbon dioxide also goes down. It means carbon dioxide deposits over there, and then it comes finally as an explosion. Now, this last 4,000 years temperature, if you see that after the period of our what we call as a Indus civilization, and then there was a great Meiomi period when the temperature was large. Now, these temperatures are reliable temperatures, because these temperatures records we have taken from the central Greenland, where the uncontaminated data is available, and blue is the real data, and the green line is the simulation. You can see there is almost correlation coefficient is of the 0.8, and based on that, what we are claiming that the temperature now in this 21st century is going to be further decrease over there. Now you can see all this as a general profile of this temperature, that almost 3000 even years before the temperature was large, and now continuously there is a decrease in temperature. Only in between for few years or few tens of years, the temperature goes up, and that is always possible, because just like in modern time, what we call is a modern global warming or so. But now modern global warming is also stopped.
अरे शुक्ला मैडम मेरे को बोल रही हैं कि वाइवा था 12:30 ना.
Hello. Am
Sir,
I
please
audible?
continue, please. Continue.
Okay. And now, if you see all these things, it means what we are predicting that appears to be now correct, that the temperature in this 21st century is going to be reduced. Now, it is very important. If it is going to be reduced, then when? So, if this sunspot cycle 25 will tell us that what will be the future of this 21st century. If it is really going to be a slightly minimum, then the 26th and 27th sunspot cycle will be further, of weaker and weaker. And finally, at the 2045 or near 2050, the ice age will start, and the whole then the remaining 50 years or 70 years, even of the next century, will be under the ice age. And although in India we are fortunate, it is a warm country, but the cold waves will come from the west side, that is Europe and America, and that will kill to the many people, even in India also, and many viruses in the other countries also may be seen. Okay, this is what I was telling, that my student Krunal Patel is doing the work with the sea surface temperature measurements in Gujarat near the Indian Ocean at the Khambat, Gulf of Khambat, and then Kutch, etc., and in Saurashtra. Now you can see the sea surface temperature, that is the blue dots over there, and the red is carbon dioxide. Now with the increase of the sea surface temperature, the carbon dioxide is increasing. Now the question arises whether carbon dioxide, because of the industrial evolution, carbon dioxide is increasing, so sea surface temperature is increasing in spite that the sunspot numbers are so low. This is a big question, and that is to be investigated. And if it is so, sea surface temperature is increasing so significantly, then what will happen to the this oceans and the villages and the towns which are very close to the ocean? So Krunal and my group whole studied this Chokdi village near the Indian Ocean, that is in the Gulf of Khambat. This is the location of this Chokdi village. This is the seashore line of the Indian Ocean, and we took the data from the NASA satellite from 1978 to 2020, and we published the paper in the Applied Geomatics, where what we claim that in last 40 years, this distance between the seashore line of this Indian Ocean and this Chokdi village is reduced. When sea surface level is rising, that is, or in other words, the distance between them is reducing, and that is what we can see over here. So the distance between the two, that is the blue dots, as a function of time, the distance is reducing when sea surface level is increasing or sea is rising. But black dots, that is the sunspot numbers of the different cycles, 21, 22, 23, 24, etc. And you can see that as numbers of sunspots are reducing, the sea surface or sea level is rising. So it is a completely now different kind of problem. Previously, we were thinking that the sea surface level is rising when the sunspot numbers are increasing. Now here we see the sea surface temperature is rising, sea level is rising when the sunspots are decreasing. So now who is the culprit? This is a big question in the space science. Who is the culprit? Sunspots are culprit, carbon dioxide is culprit, total solar irradiance is culprit, or galactic cosmic rays are culprit. And these are the questions to be addressed in next 5 years only, so that we can understand our future. And so, as I told, that the space weather, sun-earth relationship is very interesting for the youngsters, and I motivate them to take an active participation in the research in the sun-earth relationship. In order to do that, the ISRO actually gave me an opportunity in 2003 to launch solar X-ray spectrometer to detect the big issue between the USA west side and east side, whether really there are iron lines and nickel lines are there in the solar corona. And however, that required a big technology, very high sensitive detectors in X-ray emission, and then only we can see those lines. But I came up with the model that these lines are visible only when the flare takes place, even a micro flare or a big flare, but flare is necessary, and then temperature rises in the flare plasma, then only in the corona we can see these iron lines and nickel lines, etc. And our satellite was launched from Sriharikota on the GSAT-2 satellite, and it was actually installed in the geosynchronous orbit, so we can see all the time 24 hours the sun regularly and monitor the sun solar observations in X-ray. We launched 2 detectors in the solar X-ray spectrometer, silicon diode and the carbon zinc telluride detector, that is both the ARPIN diodes, but they were sensitive and we made them sensitive to the 0.5 to 4 keV to 25 keV and then 4 keV to 56 keV in CZT. And you will be surprised and really appreciate our Indian effort to see that we could detect the various small to large scale flares. You can see on this x-axis as time and y-axis as the intensity in the X-ray emission. These different colors refer to the different emissions or different energies. And you can see this here as a very small jump, that is a micro flare, then this is big flare, this is a medium sized flare. And by analyzing all these many flares, you can see in the spectrum this iron lines and nickel line. The x-axis is the actually energy and y-axis is the intensity. And based on this discovery, the astronomical telegram was sent by PRL to the International Astronomical Union. And finally, I received the fellowship of the Royal Astronomical Society in the UK as a recognition of our work. And ISRO got the big name for this. I also participated in various other satellite programs, but here I would like to take you in my last 3-4 slides only. That ISRO is actually planning in next 20 years. So youngsters must now take action immediately. That in next 20 years, ISRO is going to offer you many opportunities in both research as research scientist as well as an engineer for the space science missions which are continuously planned in next 5 years and next 20 years. Then in the technology capacity building, etc. And then in the research and development of the instrument, enabling the key technologies required for future space missions. And a team is required to take the, research prime areas for the space missions. And in this, there are many areas are there, but I would like to just tell briefly about the few areas related to the Sun-Earth relationship, and ISRO has a prime objective to study this. So solar activities mechanism we want to study and predictions. Similarly, propagation and evolution of interplanetary disturbances, multi-scale physical process in different wavelengths of these geostorms, etc., and the solar explosions, basic plasma physical processes. We want to do the not only this basic physical processes that affect on the Earth, but the modeling also is required. Then the physics-based numerical space weather programs and the effects of the solar storms, explosions on human activities and effect of these adverse conditions on the climate. So in order to do that, many programs are there. And as an engineering, as a technology development, there are many programs of the ISRO for the next 20 years. Actually, ISRO is planning also to put up the large aperture optical telescope of more than 1 meter in diameter. High resolution X-ray imaging is a prime area where we have to do the lot of work. Extremely high energy cosmic ray observations are required. Then similarly, the very long baseline interferometer in millimeter wave, that is radio astronomy program, is required from the space. Then comprehensive geospace exploration missions will be there. Interplanetary space solar wind observations are required. And then we want to probe at in the Lagrangian L1 point as well as L2 point also. So various Lagrangian points which are promising for us. So we would like to install our satellites in those orbits. Then complete monitoring of solar activity, and then to explore the relation with this. Now, what is that? What are the future, just in next 1 year or 2 year missions which will go from the ISRO? I would like to tell you, friends, that this, whatever we launched in Chandrayaan-2, the one part, that is the lander with the rocket, we could not got it. I mean, we could not achieve the success which we wanted. So Chandrayaan-3, which will be launched in this year, it will be the same thing again. It will be repeated. That is lander with the rover, and rover will be again, I mean, installed with the 2 payloads, which will discover the subsurface elemental composition and their structure and characteristics, etc. The ISRO is planning to launch Gaganyaan, that is a satellite with the astronaut, and to study our atmospheric conditions, then the space condition, interplanetary conditions, etc. Then this year or early next year, at a suitable time, the Aditya, that is a completely dedicated solar mission. As I told, that the sun is a very prime target for the ISRO, and Aditya will be launched, and it will be launched in the L1 orbit. L1 orbit, as I told, that there are 5 Lagrangian points between the sun and earth in orbiting system. Now, what is the Lagrangian point? Means a point where the main body, that is the main star, and the orbiting body, their gravitational pull becomes almost 0. So it comes to the, balanced stage. And at that balanced stage, if you put any small satellite or a object, then it will start to rotate in 24 hours. That is geosynchronous kind of a system. So it will take continuous 24 hours observations. So at this Aditya, which will be launched, so it will be put up here at L1 point, and it will see slightly at a higher altitude, but the continuous observations from the sun. Aditya mission is actually planned with the various kinds of instrumentation. Many are the first time, that is ultraviolet imaging telescope, then the visible line coronagraph will be there, X-ray imaging and X-ray spectroscopy instrument will be there, charged particle detectors will be there, and the first time in the history of our Indian missions satellites, we will launch the magnetometer to observe the variation in the magnetic field strength in the 3 dimensions. So with all these things, now I want to give you a last slide, and the big opportunity, a big gift from ISRO, that is the small satellites, or you can say in the American style as a cube satellites, or in India, nano satellite, pico satellites, etc. These satellites are actually to be made by the universities, by IITs, by NITs, or college like yours, that is IPS Academy. And you can come up with the research program of both the nature, either as a science research or as a technology development program. In science research, I just want to give you a few ideas. You can aim on the biological sciences, earth sciences, many things, just like snow and other discovery, then the near earth objects, etc. You can do the space-based astronomy, space weather, etc. These are few ideas, but what in this space science research, you have to come up with some original research idea, and you can make your institute, your name as a visible in the star galaxy. Then in the engineering also, there are many programs in space propulsion that we want to do, launching from the moon itself, space power. Then particularly, I would like to motivate many life sciences, biotechnology people to develop the biosensors. And do, if mechanical engineers, etc., then additive manufacturing, etc., or the steel and aluminum joints, etc., some new technologies. Or you can make taking the students in engineering and science faculties on this side and engineering faculties, combining both the sides, and you can make a very good program to design and develop a nano satellite or a pico satellite with one single objective to do something new and come up as a good name for your IPS Academy. With all these things, once again, I give my thanks to the Professor Tripathi and Principal Madam Shri Achalji to giving me an opportunity to talk to you. There were some disturbances in between, but all these things I have seen many times on the online presentations. I'm sorry for that, but now if you have time and if you want to ask questions, I am ready for that. Thank you very much.
Thank you, sir. Thank you very much.
Thank you, sir. Thank you very much.
Thank you, sir. Thank you for this informative session. Thank you.
Can you?
Yes, sir. Usha madam, you can take questions from participants.
If sunspots decreases, it means magnetic field is decreasing. Maybe that leads to cosmic ray ejections due to which temperature fluctuation occurs, by which carbon dioxide occurs. This is the question, sir.
Okay, good question. Actually, when the sunspots are large, then the heliospheric magnetic field, that is the magnetic field of the total sun, is very strong and very large, covers all the planets, and it protects them from galactic cosmic rays which are coming from the space, from the different stars and galaxies. Okay, this is the general phenomena. Now, if the sunspots are reduced, means the other source, that is galactic cosmic rays, will become stronger to reach to the Earth and even the surface of the other planets. But we are seriously concerned about Earth because human beings are here. Now, the carbon dioxide, we have to split up into two parts. The carbon dioxide, which is deposited below the surface of the Earth, okay, because of the carbon, and the carbon dioxide, which is anthropogenic, which is evolved by emissions from the industries now. So now we have to study whether carbon dioxide, which is anthropogenic or from the industrial evolution, that is increasing the sea surface temperature, number one. This is very important. In spite of that, the general temperature of the Earth is coming down, but still the seas, that is oceans, are coming up. Now, however, it has been measured by some other countries that in different oceans, now as a function of reducing this sunspot, the sea level is reducing. See, this is contradictory to my statement. It is reducing, means sea level rise is reducing. So the galactic cosmic rays are when high flux, then sea level goes down. But what we have seen, the sea surface temperature is increasing, and the distance between the Chokri village and the ocean boundary is reducing, means the sea is approaching toward the village. That suggests that the sea level is increasing. So it is only Indian Ocean phenomena, or it is universal on all the oceans, but other oceans also some people have reported, yes, it is increasing. Now so then if it is so, then it is a big question. We have to study in greater detail the galactic cosmic rays. We have to study in greater detail the carbon dioxide emission. My student is now studying the daily CO2 emission, monthly emission, etc. And we are trying to explore the periodicities. So this is a big question. But I honestly want to say that answer at the moment is in the research trend. Not final answer has already arrived. But it is sure that the sunspots are continuously decreasing, and in this century itself, there is a possibility of grand minima to start from 1650 plus minus 5 years, and there is a possibility of ice age begins. If it is so, then it is actually a warning by the earth, by the God, that we should try to protect our earth. We should try to protect our humanity. We should try to take care of the next generations. Next question.
So what is multiverse theory?
Multiverse theory. Okay. We have, in the beginning, we considered only one universe. Okay. That there is one universe And in this one universe, there are many galaxies, okay? Number, I mean, it is not millions, it is billions of galaxies, and galaxies which are very far, even they are moving away from each other. So that was the one concept of the Big Bang theory, that after that Big Bang, the one universe is actually formed. But now after this discovery of the redshift, that is, the galaxies are moving away from each other, now people think that it is maybe of not of our own universe, but some of the galaxies or some of the material which we observe, or after the one which I told, dark matter and dark energy. Now people are coming as a concept. There are many universes, and that many universe word came from that. They told that the multiverse means universe more than 2 or 3. So currently people are talking about the multiverse, and they are also trying to get some practically with observation some result. But so far it is a theoretical concept. Observation wise, it is not, I mean, confirmed. Next question.
Sir, there are 2-3 more questions, but we are in short of time, so we will send you that question and then you can answer them.
May I ask a question?
Okay, sure. Please go ahead.
Sure, I am 42 years of age. I am completing my research in cosmic rays.
Okay.
So how I can become eligible for applying for the post of research scientist in ISRO?
Oh, okay. You have done MSc, you have done PhD and you can apply at 3 places. One is Vikram Sarabhai Space Science Center at VSSC in Trivandrum. Okay.
Yes, sir.
That is in Trivandrum, Tirunelveli.
Yes. Yes, sir. Yes, sir.
I mean, some laboratory, NARL, or it is known as NARL in Hyderabad. Okay. And you can, but what you have to do is you have to plan, you have to prepare a proposal, research proposal, what you will do. And that research proposal should be very original and innovative. Then only you will get the position. Okay. Have you done a lot of research work in considering your cosmic rays observations, or only statistical? Hello? Hello, can you hear me? I'm audible?
Yes, sir. Can you repeat what you have said, sir, please?
That gentleman heard my statement. What I want to say, that when he applies, then he has to submit a very good original and innovative proposal, what he wants to do in ISRO. And that should be very, I mean, creative work is required. In ISRO, you must be aware also that they take whether youngsters or the engineers or at any other stage, but very creative people who can really contribute significantly and potentially. So he may review his own proposal, and then he can apply the places which I told, VSSC and NARL and other places, even at Physical Research Laboratory also. And then he can think of what. Okay, I'm audible? Hello?
Yes, sir. Yes, sir. You are audible.
Okay, because in between the pictures become freeze. Okay, I think all the questions are over. I am ready to address any other question.
Hello?
Yes, I can hear you.
Hello?
Hello, yes.
Yeah, I have a specific question. I have gone through your presentation and it was very informative. I am Dr. Nishant Sirse from IPS Academy. And in your presentation, I saw that there are many possibilities about including the chemist, bio people, searching of life. My question is, how do you think that we can include multidisciplinary at the level where we are having only limited resources at our universities, for example, and to give some basic demonstration experiment, which will actually show some kind of output where and also some laboratory experiment to the students also. So my question is about how do you think that we can actually explore this possibility at a university level, where we can actually introduce this subject at initial level to bring the force work for the coming period for space science.
Okay. Now I'm audible to you. Yes.
Yes, sir. You are audible.
Okay. So first of all, this space science program you can start space science as a general. Okay. Don't take only as astrobiology, but space science in which astrophysics, astrochemistry, astrobiology, that is the one thing. And then you can invite some experts also to give lectures as well as demonstration, practical demonstrations. Although current time is the Corona time, so I don't think anybody will come and physically, but you can start like that. This is space science program. That is number one. Number two, you can write, your principal can write a very good letter to ISRO chairman that you are planning to start a space science program to participate in space research and engineering development with the new plans of ISRO, etc. So you can think of that kind of thing, and you can get a good support from ISRO also for that. And ISRO faculties may come to give lectures and to give demonstrations. I think that will be a good start. And particularly you include the MSc students for this kind of a program. And once you are in the line and in tune with the ISRO, then you can have much more, even research proposals also can be considered favorably. On the other hand, you can motivate your faculties and students to always participate in international schools related to this kind of subjects, multidisciplinary subjects, particularly say for astrobiology, etc., space biology. That will help a lot. Okay, and if possible, for 1 or 2 students to participate in that, you can find out the budget from your place, but I can recommend names so that they can get entry in this international schools over there. Okay.
Thank you, sir.
Yes.
Thank you, sir.
Okay, thank you. Other question?
Sir, there are 2-3 questions. We will mail you since we are short of time, sir.
Okay, please mail.
There is another session from 1:30, sir. Second session will start from 1:30 onwards. So
yeah,
two onwards.
Okay.
For your very informative lecture, really we are feeling proud to listen.
Okay, thank you very much, and thanks to all of you, and say my namaste to Achalji also. Very good. Thank you very much.
Sharma sir is also there, sir. He is listening your lecture. ML Sharma sir.
Acha, ML Sharma also. Yeah. Okay. Namaste, Sharma ji. Thank you. And
about more than 800 professors and lecturers from different academic institutes are listening your lectures all over the nation.
Okay, thank you very much.
Yeah.
Thank you.
Sir, your lecture was wonderful. We definitely benefited, and a student will definitely take this opportunity to join space. We definitely motivate our students.
Yeah, you should motivate. There was a very good suggestion as a question, but from one of your faculty, and I strongly recommend that you should form a space science group over there.
Sure, sir. Sure. We definitely try our best, sir.
And I'm sure you have engineering also over there in your institute.
Sir. Yes, sir.
So you should shake hand with the science people, should shake hand with the engineering people. Okay.
Okay.
Okay, good, nice. Thank you very much.
Thank you. Thank you so much, sir.
Thank you.
sir. Thank you. Thank you.
Thank you. Okay.
I would like to ask all the participants to please open their videos so that we can have a photograph session.
तो स्क्रीन शेयरिंग स्टॉप करना पड़ेगी आपको.
Oh, okay. I will do that. Done. Is it done? Screen share is stopped, right?
Yes, sir.
Professor A.K. Srivastav is also there.
Yes, sir. Pranam, sir. Good morning, sir.
Yeah. Yeah.
Yes,
Pranam. Yeah.
I am wearing, sir, mask. So you.
Oh, screenshot is taken over. Can I leave now?
Yes, sir. Usha madam, you can continue.
Yeah.
Just 2 minutes more.
Thank you, sir, for your wonderful lecture. I am sure that all the participants have definitely enjoyed your lecture a lot. Now, this is time to propose vote of thanks. I extend my sincere thanks to our eminent speaker, Professor Rajmal Jain ji, for his so interesting talk and giving us his vital time from his busy schedule to grace this faculty development program. My sincere thanks to our president, Achal Chaudhary sir, for his all-time moral support and guidance, and to our principal ma'am, Dr. Premlata Gupta, for continuously motivating us. I express my gratitude to Dr. Pradeep Joshi sir, who is HOD of Mathematics Department, convener of this faculty development program, and members of the organizing committee, Dr. Sanjay Nagar, head of the Department of Biotechnology, Dr. Jitendra Tripathi, head of the Department of Physics, Mrs. Ruchi Srivastava, head of the Department of Chemistry, and Mrs. Sapna Jhalore, in charge Department of Library Science, for organizing this faculty development program. My sincere thanks of gratitude to all the members of the academic committee as well as technical committee, without which it would be impossible to conduct the program smoothly. Further, a big thanks to all the participants for making today's lecture a great accomplishment. Last but not the least, thanks are also due to all the faculty members of the Institute of Science and Research, IPS Academy, who directly or indirectly contributed in the FDP for its proper conduction. Once again, thanks to all of you. Next session will be from 2 p.m. and the lecture will be of Dr. Sudhakar C. Agrikar. Thank you to all of you.
Thank you, sir. Thank you very much.
Thank you, sir.
Okay, thank you.
Thank you all. Thank you.
Sir.